With these problems, I'm given some point on a function. This time though, I have no idea what the function is, but it turns out it doesn't really matter. Since I know the effect that these values will have on my graph according to transformations, I don't need to know what the actual function is. So here's how it's going to work. Let's go ahead and figure out where a point on the graph of f of x plus 6 is located. Well, as we've done before, let's describe what these numbers are going to do. Since this plus 6 is located outside of the bars, this will shift the graph up 6 spaces. So specifically what that's going to mean for this coordinate is if I start with negative 3, 5, a vertical motion always affects the x or the y value, excuse me. So all I'm doing is adding 6 to the y value. My new coordinate is going to be at the point negative 3, 11. It's that easy to do these problems, okay? So next up, I've got a minus 1 inside of the bars. Well, remember, this is a horizontal shift, and it does the opposite of what it says. So really, rather than moving backwards 1, I'm going to be moving to the right 1. As specifically what this means for my coordinate, I begin at negative 3, 5, and I'll now be adding 1 to the x because I'm moving horizontally. That affects the x value, and remember, it does the opposite of what it says. So my new coordinate here will be negative 2, 5. Getting the hang of it? Next up, or on this screen at least, I've got 2 transformations to look at. This is going to move the graph in the opposite direction horizontally of what I think. So this will actually move the graph left 2. I'll subtract 2 from the x value. This, since it's outside of the parentheses, will move my graph up 1 and affect the y value. So my point, which began at negative 3, 5, I'll now subtract 2 from the x because I need to do the opposite and add 1 to the y. So my new coordinate is negative 5, 6. When I'm dealing with a table of values and not just a single point, all I need to remember is that my transformations affects all points the same way. So really, this is the same thing we just did, except with 3 points to deal with instead of 1 point. So let's take a look at these. Once again, I want to notice where that number is located. It's outside of the parentheses, and because it's a multiplier, this must be a stretch or compression. Since it's outside, it will be vertical. And the multiplier will do what it says, and it's going to vertically stretch this by a factor of 2. What that means mathematically is I'm going to be multiplying all my y values by 2, just the y values, because it's a vertical stretch in this case. So if I made my new table, I guess I'll just do it right here. My x values will remain unchanged, so 1, 2, and 3, but my y values have now been multiplied by 2. So while 0 would stay 0, but then negative 2 and 12, and this would have the effect of stretching the graph 2 times as tall. Next up, that is 1/3 is located inside the parentheses. So this is horizontal, meaning it's only affecting the x value this time. And remember, it lies to you and does the opposite of what it says. So this will actually again stretch the graph, but this time by a factor of 3. I need to do the reciprocal. And once again, what that means specifically is now I'll be multiplying just the x values by 3. So if I set up my table, my y's will remain the same because I'm not doing any vertical stretching. So 0, negative 1, and 6 were my original y values, but now multiply each x value by 3. So my new x coordinates will be 3, 6, and 9. When I'm working with reflections, like in this case because I see the negative, all I need to do is change the sign of either my x or y coordinate. Because this negative sign is located outside the bars, remember this will have the effect of reflecting the graph. Oops, really bad writing right there. But reflecting the graph over the x-axis. And specifically what that means is I'll change the y sign. If you need to see why that works, you can kind of make a quick sketch and see what's going on. If I imagine the point 8, negative 1, that's what they gave me this time, the point 8, negative 1 would be located somewhere down here, and if I reflect over the x-axis, that point would be located up here, which would just be 8, positive 1. So it may seem counterintuitive, but it makes sense if you stop and think about it for a second. My new coordinate would have a different y value to reflect over the x-axis. Okay? Over here, I'm going to be reflecting over the y-axis because the negative is located inside the bars. So reflect over the y-axis. And specifically what that's going to mean is to change the x value for the opposite reason of what we just talked about. And again, you can sketch it if you want to see why that works. This time though, not only do I have to change the sign of the x, but I need also, as we just talked about, need to multiply the x value by the reciprocal, because I have a horizontal compression in this case. So I'm going to multiply my x value, which was 8. Sorry, let me just write my point down. 8, -1. Nothing is happening to the y this time, so that stays -1. I'm going to change the sign of the x so it becomes a negative, and then also multiply it by a fourth, because I want to compress this. So my new coordinate will be a -2, -1. And then last but not least, once again, when we're dealing with a table, just remember that every single point on your function is affected the same way. So it's what we just did, just 3 and 1. So once again, I've got a negative inside inside the parentheses, which will be a reflection over the, well, let's remember, a reflection over the y-axis. This will have the effect of just changing the x value. So my new table will become -2, -4, -6, where my y values will remain the same. You can kind of see that just the way it looks. Look, it says just change the x value. The next one then, or my last one, I've got the negative sign outside, so I'll change the value of the y's to do this because I'll be reflecting over the x-axis. I also need to notice that I've got that multiplier of 2, so I need to multiply everything. I mean, you can just kind of see it too. Multiply all the y's by -2, so change the signs and multiply the y's by -2. So in my table, my x values are remaining untouched this time, so they'd stay 2, 4, and 6, but my y values, if I multiply all of them by -2, I get a +2, a -10, and a -4. So my graph has been reflected over the x-axis and vertically stretched by a factor of 2.